Welcome. My name is John Mathers, and I'm an active supporter of SRAG and RCAT, both of which I will explain in a few moments. It is a pleasure to be with you. We have a great speaker for you today, Dr. Andrew Gunther. But before I introduce Andy, let me share a few Zoom protocols and a bit about our speakers program. For those of you who don't know, SRAG is the Environmental Sustainability Rotary Action Group, whose purpose is to assist Rotary clubs, districts, and multi-districts in planning, implementing, and evaluating service projects, building awareness, and inspiring action. The RCAT network supports the creation of Rotary climate action teams at the club level through education and organization. Working together, we can make a difference in Rotary and well beyond. If you're a Rotarian, we highly recommend that you take action now. Create an action team, become a member of SRAG, join the network, and share your projects and successes. Take advantage of our many speakers to inform your club or action group on a number of climate change issues and solutions. This is just a partial list. And be sure to join us on the third Thursday of every month for our Global Speakers Program. And now, let me introduce our special speaker. Dr. Andrew Gunther received his PhD in Energy and Resources from the University of California at Berkeley in 1987. And he has worked at the intersection of environmental science and policy since 1979. He was Assistant Chief Scientist for the Exxon Valdez Oil Spill Restoration Program and the first manager of California's program monitoring toxic substances in San Francisco Bay. He was recently appointed by Governor Gavin Newsom to the San Francisco Bay Regional Water Quality Control Board, and he also serves on the Bay Conservation and Development Commission and is a member of the Board of Directors of the Union of Concerned Scientists. Welcome, Dr. Gunther.
Scientist at Exxon. There's a general scientific agreement that mankind is influencing the global climate through carbon dioxide release from the burning of fossil fuels. In 1978, President Carter was warned by the Scientific Advisory Panel of the Department of Defense, the JASONs, that this posed a serious national security threat to the United States. And Carter asked the National Academy of Sciences to double check the work of the Department of Defense. And the National Academy of Sciences drew this conclusion. This may be the greatest understatement in the history of science. And so President Carter responded as an engineer. He put solar panels on the White House, and he set a goal for the United States to get 20% of its electricity from renewable sources by the year 2000. But unfortunately, when Ronald Reagan was elected, he had no interest in this issue. He took the panels off the White House, and emissions just continued to grow into the atmosphere. And during this time, it's important to remember that, that there was an organized campaign to deceive the American people and our political leaders. And that campaign continues today. Here's an example of an ad that Mobil Oil put in the New York Times. This is absolutely false. And we can see an important example of this by looking at the work of Jim Hansen. Now, Hansen, if you probably recall, in 1988 testified before Congress that, quote, greenhouse warming was almost certainly underway. Hansen was the lead scientist at NASA, which is where much of our climate expertise had gathered as a planetary science agency. His work and the work of others at that time led to the signing of the Global Treaty in Rio. And to this day, Hansen remains a global leader in the effort to educate people about climate science and to reduce emissions of greenhouse gases. But in addition to the Rio Treaty, another response to Hansen's testimony was deceptive activity promoted by the fossil fuel industry. And by examining what Dr. Hansen told Congress, and then how his work was later fraudulently misrepresented to Congress, we can see both how well we understood the problem in the 1980s and how so many Americans have been deceived. So what Hansen did is he had a model of the Earth's climate, and he ran 3 scenarios in his model. The big uncertainty that Hansen and his colleagues faced was what would be the future emissions of greenhouse gases. So we had one scenario where emissions continued to climb really aggressively. That was scenario A, and you could see how the temperature of the Earth responds. Then he had a scenario where there was a little bit, emissions weren't quite as high, and that was scenario B that you see here. And then he had scenario C, where we decided to stop emitting greenhouse gases around the turn of the century, and you can see how the temperature of the Earth responds. Now, when we look at what actually happened, we can see that we're pretty much on target with Hansen's scenario B. Now, this campaign to deceive Americans started cranking out myths. One of their favorite ones was that Hansen was wrong and that scientists are alarmists. And this reached its peak with the testimony of the Cato Institute's Patrick Michaels before Congress in 1997. And it was also greatly amplified by Michael Crichton's 2004 book, State of Fear. And Michaels perpetrated a fraud on Congress and the American people. Let me show you what he did. The key thing that he did was he represented Hansen's research to Congress by only using scenario A, the very high emissions scenario. And then when he compared that to actual temperatures, there was this big difference. And he suggested this disparity showed that Hansen's predictions weren't coming true, thereby casting doubt not only on the entire modeling enterprise at NASA, but the entire field of climate science itself. Here is the actual graph that Patrick Michaels showed Congress. Now, of course, when you put all 3 scenarios back on the screen there, then you realize that in fact that difference is very small and that scenario B is a very good match to actual temperatures. The narrative here that scientists are hyping worst cases, that they're alarmists, that they're fear mongers, not only have I shown you that this is a myth supported by fabrications, but it's also just plain wrong. Science is a very, very conservative enterprise, and it's conservative in 3 key ways. First of all, it's the standard of proof that scientists use. We all use different standards of proof, more likely than not when we make decisions or beyond a reasonable doubt. Scientists use what in the language of statistics is called the 95% confidence limit, which is essentially the chances I'm right are at least 20 to 1. And this statistical convention that's used throughout science essentially represents a value judgment. The value it reflects is one that says the worst mistake a scientist can make is to think an effect is real when it's not. You can think of it as wanting to be sure you're not being gullible or fooling yourself, that you don't have undue faith in your own ideas. Right? You can think about this going right back to the motto of the Royal Society, right? Don't take anybody's word for it, right? And Naomi Oreskes at Harvard points out that, in essence, scientists play dumb on purpose in order to make sure that they are not accepting something as true when it's not. But of course, this means science is prone to a different kind of error where you are too conservative and you miss causes and effects that are really there. Secondly, scientists are reticent to be seen as speculating or alarmists. The vast majority of scientists do not speak in public at all. When they do, they speak in probabilities, not certainties. Even if their conclusions are alarming, they don't use alarmist language. And Jim Hansen has called this a culture of scientific reticence. He says that scientists are reticent to conclude and communicate scenarios that would be disturbing to employers, funders, governments, and the public. And third, scientists don't project what they cannot yet model. Even though we really expect that there are tipping points in our climate system where if we go beyond them, the climate starts changing on its own, independent of human emissions, we don't understand these things, so we don't yet include them in our major models. And we're only just starting to get into this, and I'll talk about one of these examples in a minute. But at the moment, that means that scientific culture and convention leads to underestimating future risk. So scientists are anything but alarmist. And indeed, now we can see with our own eyes and instruments that what Arrhenius and Tyndall and Hansen and all climate scientists have predicted is coming true. The Earth is getting hotter. There are 5 independent data sets. They all show the same thing. Moreover, the distribution of heating shows what we call Arctic amplification. You can see that it's hotter in the Arctic regions than the temperate regions. This pattern was predicted by the Department of Defense and the National Academy of Sciences back in the 70s when they reported to President Carter. Now, some people might say, wait, humans are very adaptable creatures. We can deal with a few degrees temperature rise. What's the problem? So one way to look at that is to say, okay, so what have the temperatures been during the time that human civilization has flourished, which is about the last 10,000 years. And so if we look at the temperature over the last 10,000 years, this is what we see. Temperatures increased about 1 degree Fahrenheit over 5,000 years, and then they went down again during the next 5,000, except right at the end where you can see the temperature has gone up almost 2 degrees Fahrenheit in just 200 years. And that represents the changed climate due to our emissions of carbon dioxide to the atmosphere. And here's where we're going if we just keep business as usual. Now, how far up the graph we go is up to us, but we're already committed to a lot of this. And that's because we've altered the atmosphere like the Earth has not seen in over 800,000 years. And I'll show you, the next slide is data from an ice core in Antarctica that shows over 800,000 years, the blue line is carbon dioxide, the white line is temperature, and you can see where we are today. And if we keep going, and this, by the way, is the source of the urgency in the scientific community's message, because carbon dioxide stays in the atmosphere for a long time. So all the time that it's in the atmosphere, it is absorbing heat energy that would otherwise have escaped into outer space and pumping it down to the planet, that the intensified greenhouse effect. And if we don't transition away from fossil fuels, if we keep doing what we've been doing, this is where we're going to be in just another 40 years. And scientists are basically saying that this would result in a future warming that makes it unlikely that human civilization can survive as we know it. Now, how do we know this isn't some natural phenomenon? That's a great question, and scientists have been investigating that question for decades. The easiest way I've come to think about this is to recognize that the Earth is a huge thing. And if you're going to change its temperature, you have to have an enormously powerful source of energy. And in fact, the only source of energy that powerful is the sun, or derivations from the sun's radiation. Now, there are a couple of ways this could happen, where you could have a situation where the Earth gets closer to the sun. Well, that would warm the planet up. And in fact, the Earth's orbit oscillates. It's an ellipse, and sometimes it's more elliptical, sometimes it's less elliptical. And when it's more elliptical, the Earth spends more time further away from the sun. And that's one of the drivers of the ice ages. And you can see the ice ages in those dips in temperature on the screen. But those variations happen on a scale of 40,000 to 100,000 years. So that can't explain what we're seeing on the scale of decades. Now, another natural variation could happen is that the sun could just get hotter. And if the sun got hotter, the Earth would get hotter. And in fact, the sun's output does vary, and it varies on a scale of decades. But when we measure it, which we can do very accurately now with satellites, we find out that the sun's output has actually been declining over the last several decades. And the variations themselves are not enough to explain the change in temperature that we are measuring on the planet. When we take these natural variations and we put them into a model, say, of ocean temperature, this is what we get. This is from Tim Barnett's lab in UC San Diego. And those dips, low dips, represent volcanic eruptions, where a volcano puts dust in the atmosphere, acts like a parasol over the Earth, but just for a couple of years until gravity pulls the particles out of the air. Now, if we then put into the model the greenhouse gases that we know are in the atmosphere, then this is what the model says. Wait, ocean temperatures should be more in this green zone. And now we have an experiment, and we can test this because we can measure the temperature of the ocean. And when we measure the temperature of the ocean, this is what we see. The key point here is that there's no way to explain what we are measuring except for the impact of greenhouse gases. And for you fans of logic out there, there's no way to explain why greenhouse gases are not causing this, which is a separate question. And this is why the US Supreme Court held in 2007 that US EPA has to regulate greenhouse gases as a threat to public health and safety pursuant to the Clean Air Act, because there's no other explanation for what is going on. Now, we are seeing another signal that we're seeing besides rising temperatures is the decline of the Earth's ice, the Earth's cryosphere. We're seeing it in the Arctic. The Arctic ice cap is shrinking. I'm going to show you a time lapse here, and the graph shows you the thickness of the ice, or which the ice is, where the ice is older, and you can see there's a lot of old ice here in 1984. Now we're going to run this through to 2016, and you're going to see both the extent of the ice cap shrinks. You're seeing the variation in the winter and summer, and then also the thickness of the ice, how old the ice is, changes drastically. So here you have it, right? So in 1984, it looked like this, and there was lots of old ice, old thick ice, and in 2016, it's greatly reduced, and there's very little old thick ice, right? The ice cap is shrinking in 3 dimensions. Now, I had a chance to see this firsthand because in the summer of 2019, I stood where that red dot is, and this was what the Beaufort Sea looked like. We luckily had a beautiful day, and the wind has blown some icebergs into the coast, but if you look on the horizon, you can see there is no ice pack. My guide told me that 25 years ago, we would have easily been able to walk out onto the pack ice in early July. We're similarly seeing a large loss of ice in Antarctica as well. And this kind of, climate is the envelope in which everything happens. All of human enterprise and all of our natural systems. And when you change that, you can change everything. So climate disruption is going to affect the availability of water, the productivity of farms and forests and fisheries. These 2 things are going to make it increasingly difficult to feed the population of the world. In California, where I live, we're already seeing a change in the availability of water. This is a change that was predicted decades ago. What's happening is that more of our precipitation is coming down as rain instead of snow as the earth warms. And that means that the spring pulse of fresh water when the snow melts, that pulse of fresh water is getting smaller because there's less snow, because we've had winter precipitation as rain. And that is just what we're seeing here in the Sacramento River, California's largest river. The snowmelt pulse is getting smaller. We're going to see an increase in the prevalence of oppressive heat and humidity. Right? Here's a sample of what it's going to look like in Santa Clara County. This means that Santa Clara will be as warm as Amarillo, Texas, in the end of the century. But we determine how hot it will be, right? If we are aggressive in reducing the amount of emissions, then this is what it will look like at the end of the century. So this change in heat is leading to leading health experts saying things like this, not only because of the heat, but also because we're going to see increase in the concentration of air pollutants, because photochemical smog is a temperature-dependent product. We're going to also see a change in the geography of disease. The whole idea of tropical diseases, that idea exists because the creatures that transmit these diseases to humans live in the tropics. But no more. Aedes aegypti, the Asian tiger mosquito, is now well established in North America. This is the creature that transmits dengue, yellow fever, chikungunya, and Zika between people. And it's resulting in, for example, in Florida, people seeing things like this. It used to be that dengue in Florida was because somebody got bit in the Caribbean and flew to Florida. Now people who haven't left Florida can get dengue fever because they can get bit by a mosquito that has the virus in it. We're going to see increased damages from storms, droughts, and wildfires. We're all living this right now. We're going to see property loss from sea level rise and coastal erosion. And we're just seeing a complete alteration in the distribution and abundance of species on the planet. There's been an incredible decline just in the last 40 years in fish, birds, mammals, amphibians, reptiles, insects. And this decline is because the ecosystems that support these creatures are being disrupted. And of course, these are the same ecosystems that support us. When we look at sea level rise here in the Bay Area, we happen to have the oldest tide record in the Bay Area at the Golden Gate. And we can see here that there's been about 7 to 8 inches of sea level rise since 1900, but about 3 of those, almost half of that rise has occurred just since 1993. And in the future, sea level rise is going to accelerate, but it depends upon our emissions, again, just like the temperature. The blue line is a much more limited emission of carbon dioxide. The red line, and you can see the red has its own uncertainty. The blue has its own uncertainty. The red line is a less controlled future of carbon emissions. Please note these are curves. They're not straight lines. What this means is that sea level rise is going to be going up faster in 2100 than it is today. It's going to take a long time for the great ice sheets to come into equilibrium with the increased temperature of the Earth. Now, there's also another scenario that has been recently added by California's Ocean Protection Council to California's planning efforts for sea level rise, and it's this one, which is 7 to 9 feet of sea level rise by 2100. This is there not because it's likely, but because we're recognizing that it's actually plausible. For the first time here, we're beginning to put some of those effects that we're just learning to understand into our models. And particularly, this is around the breakup of the great ice sheets. We've never really seen this before, but it's becoming more and more clear that there are ways the ice sheets can break apart very quickly, dumping a lot of ice into the ocean and raising its level. Sea level has risen this fast before in the geologic record. And so this is something that we're beginning to understand is possible. Right now, we can see what the future high tides are going to look like just by looking at our king tides, our highest tides of the year. In the Bay Area, we have a lot of transportation infrastructure around the shoreline. That transportation infrastructure is very, very vulnerable to sea level rise. We're also seeing more coastal erosion. This apartment building in Pacifica is an iconic example. This is, of course, just one building in one town, and there are hundreds and thousands of such buildings around the United States. Another key factor that we need to recognize is that warm air holds more moisture. This is something you can demonstrate on a high school laboratory bench. And when it rains, then there is more water in the atmosphere to come down. And we are seeing more downpours all over the country and indeed all over the world. These are extraordinary events. Meteorologists are calling them rain bombs. And it's just every month. You see it somewhere else. Washington, D.C. had a month of rain in the morning. We're seeing it right now with the impact of Hurricane Sally in Alabama and Mississippi. Sometimes this precipitation doesn't come down as rain, but can come down as hail, which is an extraordinarily challenging problem. And this just obviously brought Guadalajara to a standstill until it melted. And of course, increasing temperature is driving increasing aridity, particularly in the West, and we are seeing these incredible fires, right? The fire season is now 105 days longer in 1970 than it was in 1970. The fires are more intense and larger, making it very difficult to fight them. And it can impact people far from the flames. This was bad in the Bay Area in 2017, but it was even worse last week. This is now a regular feature of living in the West. But with all of these effects, the one that keeps me up at night is the political cascades of events that can ensue when people don't have enough food, water, or shelter, and they have to move. In 2007, R. James Woolsey, the ex-director of the CIA, and his colleagues produced a report, and this is what they concluded. profoundly disquieting. We all have to decide what is profoundly disquieting to us. I wasn't quite sure till I saw this picture. This is profoundly disquieting. So must we change? The answer to this question is clearly yes. So the second question was, can we change? And all I can say is, thank goodness the answer to this question is yes as well. Humanity already possesses the fundamental scientific, technical, and industrial know-how to solve the problem. This is from the work of Stephen Pakula and Robert Sokolow of Princeton. I'm going to give you an illustration of how they went about thinking about this problem. So the yellow line going up represents our total emissions. This is where we are now, and we need to head this direction if we're going to deal with the climate crisis. And that means there's this big triangle of emissions we have to forego. Now, it seems like an enormous problem, but you have to recognize there's no silver bullet here. There's no single technology that's going to answer the problem for us. And the answer is actually silver buckshot. We slice this up into pieces based on different kinds of policies and actions. I'm going to show you 5. Sokolow and Pakula and Sokolow had about 13 different possibilities. The 5 are the ones I think personally are the most important. First is energy efficiency, just the idea that we can get the services we need and want, but use less energy doing so. California has already shown how straightforward this is to do. This blue line is the electricity use per capita in the 49 other states of the Union. The green line shows where California is today. This is because when Jerry Brown was governor the first time in 1980, California adopted energy efficient building standards and energy efficient appliance standards. New refrigerators today use 85% less energy than they did in 1980. They still keep your food cold, and that's the service you need. You get the service with the same amount of energy. The Natural Resources Defense Council estimated that if the rest of the nation had improved as quickly as California, US greenhouse gases today would be 25% lower. We're also going to see new technologies arising, like LED lights. They were a novelty 10 years ago, but they're going to take over the lighting market. They use 1/10 of the electricity. They last 10 times as long. Indeed, as Amory Lovin says, saving energy costs less than buying it. And that's the fundamental economic fact that can drive incredible efficiencies into our economy. The next slice of the pie is electrifying transportation. And this is something that's just beginning and needs to move much faster. About 7% of California vehicle sales last year were electric. And there are 2 at my house. They're great. And we are going to see this really expand because the price of electric cars is going to drop below the price of fossil fuel cars. And that is because the price of batteries is declining very, very quickly. And the market for electric cars is going to explode, particularly because of decisions being made in India and in China. And auto manufacturers around the world are responding to this market. And so there's going to be growing numbers of opportunities for electric vehicles. Certain transportation sectors are going to, I think, be first, like buses. Right now, 99% of the world's electric buses are in China. But that's going to change. New buses must be electric, all electric in California starting in 2029. And California just adopted the advanced clean trucks rule, which is going to drive higher and higher percentages of truck manufacturers' sales being electric vehicles starting in 2024, and by 2035, most new trucks will be required to produce no pollution. The next slice of the puzzle is that electrifying is carbon-free electricity, generating electricity without using fossil fuels or capturing the carbon produced by fossil fuels. We have the technology to do this. Wind in particular in North America is an incredibly large resource, but globally, wind could supply worldwide electricity consumption 40 times over. Wind is expanding because the price is dropping both for onshore wind and for offshore wind. The same thing is happening for solar energy because the cost of solar cells has declined so greatly. This has resulted in solar being adopted much more quickly than was just projected by the International Energy Agency 10 years ago. I thought this statistic was pretty remarkable. Gives you a sense of how many people are adopting solar in California, but it's not just in California. Solar is beginning to show up in places you wouldn't expect it, like the Kentucky Coal Mining Museum, which put a solar array on its roof in order to save energy costs. We've been generating electricity from solar energy in California since 1980, and the prices are coming down and utilities are responding. So Nevada's NV Energy signed an agreement to purchase solar electricity at 2.4 cents per kilowatt hour, which was the lowest price paid at that time in the United States. The same thing is happening in China, where electricity is being produced for much less than the price of coal. The same thing is happening in India, where solar power bids were 24% lower than the average cost for coal-fired electricity. And it's not just large utilities. Solar is spreading into the developing world on much more smaller scale. Kenya has a very, very widespread solar energy program, and this is being facilitated. It's not a technological issue with the solar. It was figuring out how to do pay-as-you-go because lower initial costs allowed people to adopt them. And the spread of cell phones is what has allowed people to conduct transactions, small transactions for their electric power very easily. Another slice of the pie is what we call natural carbon solutions. So carbon is part of an ecological cycle. There's a fixed amount of carbon on the planet, and it's constantly changing form. And because carbon is part of an ecological cycle, ecosystems can be part of the solution. And so I'll show you now a picture of the carbon cycle, just so you can get a sense for this. There's carbon dioxide in the air. It's taken up by plants. That organic carbon makes its way into animals. So animals breathe carbon dioxide out as part of life. It's taken up by oceans. It can be drawn into mineral sources and become fossil fuels. And then, of course, we're burning those fossil fuels at an ever-increasing rate. So we're pumping a large amount of carbon on this part of the cycle up into the atmosphere, and we want to accelerate the withdrawal. And we can do that using techniques that are under the title of regenerative agriculture or healthy soils. And here's a picture that shows you on the left a plot of land being farmed using regenerative agricultural techniques, the same company using not using those techniques on the right. This is not tilling the soil and planting cover crops and planting down through those planting your crops down into that soil, and as a result, you get this very, very rich soil. It's a win-win for farmers, and a lot of people right now are trying to figure out how can we pay farmers for the public benefit they generate by drawing carbon out of the atmosphere. That will be a very important source of revenue for farmers, and there's a lot of work going on in this area. In addition, these soils drain better. So during the floods last year in the Missouri River, on the left is a plot of land using regenerative agriculture techniques, and you can see that it drained, and the farmer was able to get out and plant crops, whereas on the right, the soils didn't drain, and that was the key impact to farmers of this springtime flooding. The soil was too wet for them to get out and plant. So the last piece of the puzzle that I'm presenting here is the idea of putting a price on carbon. Right now, we live in this market economy, and a market economy effectively allocates resources when the price in the market reflects the cost of production. But that's not what we have right now. we have a situation in which many of the costs of production are external to the market. This so-called external costs, this is something you run across on page 3 of any microeconomics textbook. And for us, the main external costs are health impacts of the particulates from burning fossil fuels and changing climate. But recent research from Duke University demonstrated that the health impacts are so large that if we transition away from fossil fuels, the health benefits alone will pay for the cost of the transition. The climate benefits are actually just a free add-on. And not only do we need to internalize the cost of carbon, but we also need to stop subsidizing fossil fuels, which we do at a much higher rate than we subsidize renewables. So you can see then that with these 5 slices, and there are others, as I said, we can get at that whole triangle of emissions. But as we delay, our job gets much harder, right? We need to go this way. But if we continue to emit carbon, we're going to reach a point where to get to where we need to go is almost like jumping off a cliff, and we won't be able to do it. If we had taken President Carter's advice, we would have had a much more gradual path to follow to get to where we need to go. Our economy is growing in California as we reduce emissions, although this rate of emissions reduction is only a small down payment on what we will need to do by the middle of the century. California set a goal that by 2020, our greenhouse gas emissions should have been equal to 1990 levels, and we hit that goal 4 years early. The explosion in renewable power is generating enormous numbers of jobs, and this is a huge economic benefit that is felt in rural America as well as in urban America. Wind power is a real growing source of employment. This is an amazing statistic. The solar installer and wind power service technician are currently the fastest growing job categories tracked by the Bureau of Labor Statistics, and that's projected to continue at least through 2026. There are 5 times as many jobs in solar as there are in coal mining. Economists tell us a very simple statement, which is that the most expensive thing we can do about climate change is nothing. And the same is true, right, for this idea of the Green New Deal, or whatever you want to call it, any kind of project at scale. Leading Republicans are telling us that we can't afford the Green New Deal. But a true economic analysis concludes that we can't afford not to do something like it. Analysis after analysis has shown basically the same thing. Spend a small amount of gross domestic product now or face a much higher bill in the future. And in fact, Sir Stern just changed his worst case scenario now to 50 times the investment. And we're going to make many of these investments anyways. The idea here is that as we change over our capital stock, we need to do it with an eye towards the conditions that that capital stock will exist in the future. Now, 1% of global gross domestic product is been estimated to be approximately what we spend as a society to go from a society that used chamber pots to one that had sewers and indoor plumbing. Most people think that was a great investment. So, can we change? The answer is yes. But remember the third question, will we change? Well, we are. The real question is, will we change fast enough? And that is where Rotarians can come to the rescue. You are all leaders in your community, and you can help make this change. We can see that the change is already underway by looking at what's happening in the coal-fired electricity sector. And it's not, you don't just have to listen to people like in the Sierra Club. The president of Appalachian Power, West Virginia's largest utility in one of our proudest coal states, had this to say to his Republican governor. We're not going to build any more coal plants. That's not going to happen. And you can see that this is coming true. Here are plants that were proposed but weren't built. And then existing plants have been retired, and many, many more plants are scheduled for retirement. This is basically like canceling coal-fired electricity in the United States. Indeed, during President Obama's first 4 years, 15 gigawatts of coal plants were shut down. In President Trump's first 2 years, 20 gigawatts of coal-fired power plants were shut down, despite his rhetoric about wanting to have more coal being burnt. The latest casualty is Unit 4 at the Robert Scherer power plant. This is the largest coal-fired power plant in North America. Unit 4 is going to close in 2022, and one of the unit's co-owners, the municipal utility in Jacksonville, Florida, said the decision to close the unit will, quote, lower operating costs and substantially reduce operating risks for its ratepayers. In Indiana, another one of our proud coal states, the Northern Indiana Public Service Company will close all of its coal plants by 2028 and transition to wind power. This is going to save their customers billions of dollars. And NIPSO currently produces 65% of its electricity from coal. This is a huge transition. And so we can see that coal consumption in the United States is back down to 1978 levels. It continues to drop. And for the first time ever, electricity generated by renewables is now more than the electricity generated by coal. If you had told me 15 years ago that the world, every country in the world would get together and agree we have a joint problem we have to work on, I would have told you you were dreaming. But that's what happened in Paris in 2015. And despite President Trump's incredibly short-sighted decision to withdraw from the Paris Agreement, which, by the way, doesn't officially go into play until 2 days after the United States election in November, we see that Americans are committing to maintaining our commitments under the Paris Agreement. And again, your state may be listed here, and there's lots of activity going on in the United States. And that's because we, as citizens, have to be the change that we want to see. Right? We can do this in a number of ways. First is our transportation and our food choices. So in transportation, can you drive less? Can you walk? Can you carpool? When it comes time to buy a new vehicle, please, please consider buying an electric vehicle. If you haven't driven one, just go drive one just to see what it's like. They're quiet, they don't vibrate, there's no gasoline smell, they have 1/10 the number of moving parts, so they need much less maintenance. They're really peppy, and you have a feeling, of course, of being part of the solution. Our food, what we eat, also impacts our own personal carbon footprints, particularly if we eat beef. Beef has a much higher carbon footprint than other foods. You can see the vegetables are way out there on the end. If you have vegan friends, they've already told you about this. I hate to tell you this, but they're right. If we were all vegans, we would have much less carbon emissions associated with our food. But even if you don't want to become a vegan, you can greatly lower your carbon footprint by eating less beef and substituting more vegetables. We need to conserve energy and water. Not only using energy efficient appliances, making sure we turn off the lights, but water, we don't realize this, but water is pretty clean. When there's a bucket of this. And we in California spend 19% of our electricity is used just to move water around the state. So conserving water also reduces our carbon footprint. We can now purchase renewable power directly. We don't have to just take the electricity offered by our utility. In many, many places around the country now, there are what's called community choice aggregation organizations, where you can sign up to buy renewable power from this organization, and your utility just delivers the power to you. And this then generates demand to build more renewable electricity sources. This is happening across the commercial sector as well. If you recall that quote from the president of Appalachian Power, Well, we can see here that this was the reason that he said that is that he was in the business of selling electricity, and he wanted Google to locate a data center in West Virginia, and Google wouldn't do it because there was too much coal on their network. We can all be politically active, and this is a nonpartisan request. Please, if you're a Republican, please consider the values that you hold dear that have led you to the Republican Party, and then use those values to advocate for solutions to the crisis, especially with Republican elected officials, and vote for candidates who understand the crisis. I was thinking about possible things Rotarians could do. One is to understand and address your community's vulnerabilities, because different communities have different issues to deal with. Is it heat, flooding, fire, or sea level rise? And this fits in very well with Rotary's traditional focus on public health issues. And then there are cross-community solutions that can be shared among clubs. I'd love to see a Rotary EV program where Rotarians help people understand that it's easy to switch to electric vehicles, and you can work to get EV charging stations sited in your communities. And most importantly, remember to talk about climate change. Talk to your friends and your family. Make them realize that the time for personal and political action is now. Right? We're seeing people respond now, and remember, you're not alone. It's happening all over the world, right? I think Senator John McCain got it right here. The unselfish concern that one generation owes to the next. This is a moral quandary because of the intergenerational nature of the effects. And we are beginning to see the younger generation speak up. And if you have not thought about what you're going to say when the young people in your life come to you and ask you what you're doing about this, I encourage you, because they're going to ask you some very hard questions and say some very tough things like this. I never want to have my kids look at me and say they'll never forgive me. Remember that the climate change that's coming in the next 20 years has already been decided by the emissions we've put in the atmosphere. That blanket is already there. The question is whether we're going to take action today so that 30, 40, 50 years from now, things are different. That's the question of our time, and Rotary is poised to make a big difference. I hope you will all consider the words of Apollo astronaut Rusty Schweickart. He said, "We are not passengers on spaceship Earth, we're the crew. We're not residents of the planet, we're citizens." And the difference in both cases is responsibility. Thank you so much for your attention, and I'll be happy to answer any questions that you have.
Thank you, Andy. Very much appreciated. This is the second time I've heard it, and I love it, and all the data, it's wonderful. We're almost at the top of the hour, so we have a number of questions. Please, everyone, take advantage of the opportunity to fill out our poll, and so that we know what you think of these meetings. And if you have suggestions for other speakers, please put those in the chat. Much appreciated. And Terry, do you have some questions for Andy?
Well, yes, I did, until all of a sudden my screen, let's see in the chat. So Andy, can you see the chat box? It might be easier for you to actually scroll up and start the questions than for me to read them. Some of them are a little bit technical in nature, but if you want, I can read them to you.
Okay, well, let's see. I can see some questions if you want me to go ahead. Can I get permission to show this to my club's RCAT? Well, please direct that to John. It's certainly fine with me. On your graph going back 800,000 years, what caused the spikes in carbon dioxide levels? Right, so there was the variability, right, the cycles. And the main thing that happens is that once the Earth starts, let me see if I get this right now. Once the Earth starts getting closer to the sun, it's mainly the variation in the Earth's orbit, right? So as the Earth gets closer to the sun, the ocean warms up and carbon dioxide begins to evolve from the ocean, just like it evolves from your Coke, right, as it warms up. That adds more carbon dioxide to the atmosphere, which then warms the ocean up further. And that's how carbon dioxide then rises. And then, of course, plants expand, and there's more respiration. So And then as the Earth cools, the same thing happens in reverse. Let's see, question.
How about hydrogen-powered vehicles was the next question.
Okay, great. You got it now, Terry? Okay.
Yeah.
Hydrogen-powered vehicles. Well, I mean, it's right now we make hydrogen from natural gas. And so, and there's a carbon emission. It doesn't have to be that way. And in fact, there's a lot of focus now on the idea of solar-powered hydrogen production. Now, a hydrogen-fueled vehicle needs to have it's a special facility, and it has to have a tank. And hydrogen has a tendency to leak out because it's actually the tiniest molecule. And so there's some technical challenges associated with it. And then the question is, if you have hydrogen a vehicle, can you drive across the country? Not really. It's hard even now to drive an electrical vehicle across the country. But the idea of using hydrogen for fleets is something that's definitely being used. And I would be surprised if it's doesn't turn out to be part of the solution.
Okay, and the next question is, how important are the solar cycle and the Milankovitch cycle to Earth's energy balance?
Very important. So the Milankovitch cycles is the Serbian mathematician Milankovitch who first figured this out. So that's the change in the Earth's orbit. And there's also the Earth changes in its tilt. It actually proceeds around its axis like this, and then it also tilts this way. So there are 3 of them. These all happen over the scales of tens of thousands of years, right? So there are, those are so the Milankovitch cycles are important. And Terry, what was the other part of the question?
The other part of the question was, how important are the solar cycle?
Right, so the solar cycles, the sunspot cycles basically over the course of decades, those are important, but the total energy change, that if you think about the energy striking the Earth, and the scientists measure it in watts per square meter, and it's right now it's about 3 watts per square meter from greenhouse gas heating. The change in the solar cycles is only on the scale of 1/10 of a watt per square meter. Now, the natural cycles made a big difference over a long period of time when you didn't have this increase in humans burning fossil fuels. But those natural cycles are all still there, but their scale is such that we're just making them irrelevant on the scale of decades because of the increase. We've increased the concentration of carbon dioxide in the atmosphere by about 43%, I think. And so that's just overwhelming on any given decade, the signal from the natural cycles.
Okay, next question. Some say that we are headed into a little ice age by 2030. Is this factored into your energy consumption calculations?
I don't know who is saying that that's the case, but there is no credible evidence that I understand of why it is that we would be heading into an ice age. The Earth was slowly cooling, as you saw in that graph over the last 10,000 years, but it's happening over thousands of years, but it's been completely overwhelmed, as we can see by the actual temperature of the Earth, now that we've added all these greenhouse gases to the atmosphere. And while I would love to be thinking that the Earth is going to cool down, there's absolutely no reason. There is no reason that that is going to happen. That all of the data that we have says that ice is melting, that the planet is warming. And it's, while there may be a couple places where for local conditions, the warming isn't as much, or maybe the temperature's dropped a little, on the global average, there's no doubt that the temperature is going up. And as I said, there's no explanation for why something like that would be true. It's just, there's no scientific evidence that we're heading into any kind of an ice age.
Okay, next question. Have chain reactions already been set in motion that can't be stopped? I heard that the fires in California have negated all of California's savings in emissions.
Well, so it is possible that the changes that have already started are significant enough that putting the brakes on is going to be, I mean, we're not going to be able to stop the changes that have started. The question is, how much change will there be? And can we keep the change to a manageable level? The shorthand is to avoid the unmanageable and manage the unavoidable, right? So, the emissions from forest fires are significant, particularly when they are this size. And are we in a cycle where we have more and more forest fires, and so there's more and more emissions that heats up the planet more, dries out the vegetation more, and you have more and more forest fires? This is the kind of tipping point that we can cross that will make our job much harder. I don't think we know yet if that's the case. The whole point of quickly decarbonizing our economy is to make it less likely that we will hit one of these tipping points, such as the permafrost melting and more carbon coming out of Arctic soils. That's another example of that. So I don't know whether we have or not. And I think that it's best, at least for me, I call myself, modeling after Cristina Figueres, I call myself a stubborn optimist, which is if we just decide, oh my God, there's nothing we can do about it, we are assuring that we're not going to do anything about it. I think we have to work as diligently as we can on behalf of our children to take the steps that we can take and to reduce the chances of tipping points like this being crossed.
Andy, we're at the top of the hour. Are you okay with us going a little bit further if people still have questions?
I can go another 15 minutes, John, without a problem.
That's wonderful. Okay, Terry.
Okay, next question. Great presentation. I own a solar company and started a tree planting project with my Rotary Club in San Francisco. What other programs do you feel would be effective for the environment that we can work on as a club?
Well, I noted like the tree planting is a great one, and it's interesting because tree planting has a couple of functions. Obviously, the trees absorb carbon, but we can't just plant trees and fix the problem. It's just one of the pieces of silver buckshot. But an interesting thing about trees is that they provide shade. Shade is an important resource. A lot of communities don't have enough of it, and people don't have a place to go to get out of the sun when it's too hot. Shade also can reduce the air conditioning load in a community. The Sacramento Municipal Utility District has had a shade tree program in place for 30 years. And what they do is they'll give you a tree to plant if you plant it where they tell you to plant it on your property. And what they do is they use aerial photography and GIS to figure out where you can plant a tree on the south side of a building, because during the summer, that's when where you get the most intense sunlight. So that's something. I think that I would just say that climate is influencing everything. And so there are enormous ways, and I would encourage each Rotary Club to think about what's happening in my community. What is my expertise as a professional that might allow me to organize Rotarians and others in the community to work on a certain program? But having a solar company and planting trees, that's great. And I also would encourage you, and I don't know whether the questioner has experienced this, but I've experienced this. This is part of why I give these presentations, is that if you're doing something to address the problem, then you have much more hope, and it's a great way to fend off feelings of despair.
Okay, now next question. Could you comment on the difference in competition and monopoly providers in speeding the transition, making a difference in climate change? Does that make...
is this monopoly providers versus competition for sale of electricity?
I'm not sure exactly whether it doesn't say whether it's an industry or, so that was from Merrill. Merrill's there and wants to clarify their question. Merrill may have signed off, but
well, to me, I think that one of the things I can comment on is that our traditional monopolistic form of utility regulation it makes sense in certain ways, but it does make for institutions that are ponderous and slow to respond. And so it's very much dependent upon the regulatory agencies in these monopolistic utility systems to provide the incentives for the utility industry to respond. And then to monitor and make sure that they're doing what they need to do. We have a big problem where I live because our monopoly utility, Pacific Gas and Electric, did not do an adequate job of maintaining what is, I think, 190,000 miles of transmission lines. And it's just an enormous problem facing it. So I think that having competition might help in that way, but then some people would argue that in a fully competitive environment like this, you might have less reliable source of power.
Merrill, you have a follow-up on that?
Yeah, with all due respect, that's not the case.
Okay, well, maybe you know more than me. Let me know.
Yeah, competition is actually more reliable, more effective, more efficient than monopoly providers. And competition is coming in more and more, as you said, with price reductions for alternatives, and they can provide it much more quickly and efficiently than monopoly providers who make a profit on their infrastructure. So they have very little incentive to change. If we can get some real competition, entrepreneurial effort, which we're getting, I believe the monopoly model, which is a 19th century model, will quickly be disrupted.
Well, Merrill, I would appreciate, would you, if you have something that you could send me, you go to my website, andrewgunther.com, and send me a link, I would appreciate that a lot. What you say, I know makes a lot of sense. And there are also, I think, ways to integrate competition into our existing network that will force action by our utilities. We're seeing, I think I mentioned community choice aggregation, and that's really a form of competition. And we're seeing people make a choice. Once they have a choice of two sources of electricity, they are choosing the renewable provider. But of course, the renewable provider is using the monopoly's infrastructure to deliver that power. And in fact, for mine, they're also using the monopoly provider to bill me and collect the money and everything. So it's kind of a hybrid in a way.
Yeah, and finally, the utility commissions that are supposed to regulate monopolies are overwhelmed by the power of the monopolies, and they haven't been able to do an effective job. The lawyers for the utilities are paid, up 10 times more than the public lawyers who are designed to counter the monopolies. So it hasn't been a fair competition in the public utility sphere either. So we have a long way to go, but I feel like their model is outdated and it will be disrupted. It's just a matter of whether they adjust to it, like some of the typewriter companies, or they go under.
Well, that's great. I'll look forward to seeing what you send me, Merrill. Thank you.
Thank
Okay,
you,
we
Merrill.
got Terry.
One more question. The drawdown analysis concludes that empowering women in education for girls globally might be very effective. Your thoughts?
Well, that's absolutely true. I think that that is an important piece of the puzzle. I don't think that would have the same effect in the United States, but it certainly has been shown that empowering women is a very, very important way of building prosperity and of reducing family sizes as well. And so, you can have your the global carbon footprint is made up by how much carbon we produce, but how many footprints we have as well. And we can do both of those things.
Terry, any other questions?
Yeah, maybe the last one here, which is kind of a big picture thinking. And the question is, can you comment on the viability of restoration on global scale, such as restoring Arctic ice, replanting forests, et cetera?
Well, the
large cooperative projects.
Yes. So one of the challenges we face now, for example, deforestation is clearly a huge problem. I talked about regenerative agriculture, but not only do we need to adopt regenerative agriculture, we have to stop the scale of deforestation that we're currently engaged in, because that is another way that we cut down forests, and the forests don't regenerate. They can turn into grasslands, and you end up with with rotting logs putting carbon into the atmosphere, or logs that are there and then burn, like what's happening here in California. So I think that these kind of global programs are also really essential because we need to understand that we're all in this together. I had a guy who's a UN climate negotiator who told me that one of his favorite lines was that there's no such thing as half a lifeboat. And we have to be able to see ourselves as a global community sharing an atmosphere. And so global restoration efforts could be really important. And that's where Rotary, as an international organization, is incredibly important. I think that until we are able to see ourselves that way, I think that we're going to really struggle. And so I would like to see both the United States as a leader in the efforts to show as a leader of the world what we can do to reduce our carbon emissions, but also to facilitate international collaboration so that we can, because we have to allow people in less developed countries to enjoy prosperity. It's not, we can't just say, well, we got this, but you can't have it. We have to find a way to facilitate them, their development, but in a manner that does not put carbon into the atmosphere.
Andy, thank you very much for your presentation. I know it was highly valued by everybody. You can tell by the comments. And I think it's been wonderful having you and having a chance to spend time with you, and look forward to more opportunities.
Okay, and I just want to say I thank all of you Rotarians that are working on this issue. It's vitally, vitally important. There's a million different ways we can do it. We can do it as Democrats, we can do it as Republicans, we can do it as independents, we can do it as Midwesterners, we can do it as coastal elites. We all have to be in this together. We have to depoliticize the response to this so that we can really begin to make progress. And I think Rotary is a great way for us to start that.
Okay, and I thank you again, and look forward to an opportunity to have you do more presentations. Remember, everybody, October 15th is our next presentation. It's Elizabeth Bagley talking about Project Drawdown, and it's going to be very interesting. Thanks again, Andy, and thank you all for participating.
Thank you, Andy. It was great.